Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun, 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip. Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and brake the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes use Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest moving planet, The ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. MESSENGER really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JWST space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, Bepi Colombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with one flyby of Mercury, the first ever, but Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. Bepi Colombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows Bepi Colombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, Bepi Colombo would head off into the Sun. Now, once in orbit around Mercury, Bepi Colombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, one European, the MPO, Mercury Planetary Orbiter, and one Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. Bepi Colombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the Sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the Sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the Sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Bepi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the Sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JWST orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by Bepi Colombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar-wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that MESSENGER failed to detect. Bepi Colombo launched in October 2018 and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is, best wishes to Bepi Colombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time! Ciao, baby!
There are a whopping 118 known chemical elements out there. Some of them are like superheroes that our bodies need to survive, while others are the ultimate villains. But what exactly makes an element bad? And what elements, despite looking scary, are actually pretty safe? Well, let's see. So, there are different categories of nastiness in a periodic table. First up, we have the radioactivity gang. These elements are like the rock stars of danger. We're talking about elements from atomic number 84, polonium, all the way to the super new element 118, oganesson, which by the way only got its name in 2016. They're highly radioactive, and you definitely want to keep your distance. Next, we have the toxic troublemakers. The US Environmental Protection Agency says they can be harmful to the environment or hazardous to our health if we breathe them in, swallow them, or they sneak into our skin. Yikes. We should definitely stay away from those guys. Last but not least, we have the reactive rascals. These elements are like the fiery daredevils of the periodic table. They're so reactive that they can start fires on their own. Spontaneously. They can even burn underwater and make a big boom in the air. So, it's best to give them some space and let them do their thing from a safe distance. As you can see, things are quite simple with dangerous elements. We all know that we shouldn't touch most of the elements of the periodic table. Most of them vary from being slightly creepy to absolutely horrifying, like plutonium, arsenic, francium, and so on. But what about the safe ones? Suddenly some elements are so harmless that you can even touch them with your bare hands. So let's take a look at them. First up, we have Mercury. Well, to be honest, it can't be called the safest option. Mercury is like a sneaky troublemaker. It's super toxic and has caused health issues around the world throughout history. But humans are curious creatures, so can we touch Mercury with our bare hands? Surprisingly, the answer is yes. You see, Mercury can't get inside our bodies through the skin, so it's totally fine to touch it without any bad consequences. Mercury is kind of like a liquid that's thicker than water, but not as thick as whole milk. However, it's really heavy because it's 13 times denser than water. So if you held a few drops of mercury in your hand, you'd be amazed at how weighty it feels. Moreover, you can even swallow it. No, it doesn't mean that you should do that. What I meant is, if you accidentally swallow a little bit of mercury, you will most likely be fine. Swallowing elemental mercury isn't a great way for it to get into your system. In fact, less than 0.01% of that tricky element actually gets absorbed by your gut. Phew. But there is such a thing as mercury poisoning. Only it's not about eating it. This usually happens when the metal accumulates in your body over time, either through salts or organic compounds. For example, activities like burning coal and mining for gold release mercury into the environment. And guess what? Fish that are higher up in the food chain can have mercury too. That's because they've been munching on smaller fish that already had some mercury in them. So if you rely heavily on eating fish, especially the big ones, you might want to be a bit more cautious. All this means that we shouldn't go wild and careless with mercury. It's still pretty dangerous. For example, it's a big no-no to touch mercury if you have any cuts. Another thing to watch out for is when tiny droplets of mercury turn into vapor. The easiest way for mercury to sneak into our bodies is through inhalation. So let's keep our distance from that tricky vapor. And also, keep an eye on things like batteries, thermometers, and lamps with mercury. But hey, here's the good news. Mercury poisoning is quite rare, so you don't need to be too scared. While mercury can be a bit of a troublemaker, as long as we're aware and take some precautions, we can still have plenty of fun without it ruining the party. But there are some elements that are much safer than mercury. For example, phosphorus. Phosphorus is like the star of the show, always shining bright. It's actually one of the essential elements for life, just like the ones that make up our bodies. Now, phosphorus comes in different forms. One of them is this waxy white substance that you can touch with your bare hands. Isn't that cool? But hold on, there's a catch. This type of phosphorus can be a bit tricky. It's highly reactive and can burst into flames if you give it the chance. And here's a fun fact. Phosphorus is known as the matchstick element because it was once used in the tips of matches to make them light up with a flick. So it's like a mischievous friend, always waiting to pull another prank on you. Definitely not something you want to store at home. But don't worry, not all forms of phosphorus are like that. There are other types, like the ones found in our bodies and teeth, that are totally safe. They're necessary for us to stay strong and healthy. There's also red phosphorus, which isn't harmful to skin, and you can safely touch it with bare hands. So, while you can touch certain forms of phosphorus, it's better to leave the pyrotechnics to the professionals. Safety first, friends! Next we have bromine. Bromine might sound like a superhero name, but in reality it's more of a sly trickster, always up to something interesting. Bromine is a liquid, which is pretty unique for an element. Most elements are either solid or gas. And guess what? It's like a chameleon because it can change color. Bromine can be red, brown, or even black. Talk about a style icon. Here's another fun fact. Bromine gets its name from the Greek word bromos, which means stench. Why? Because it has a strong smell that can tickle your nose if you get too close. Aside from its unique properties, bromine has some practical uses too. It's used in flame retardants to help keep things safe and prevent fires from spreading too quickly. So even though bromine can be a bit tricky, it's doing its part to make the world a safer place. But hold on. Before you go touching bromine with your bare hands, here's the scoop. It's not the friendliest element to play around with. Bromine is quite reactive and can irritate your skin if you're not careful. So, it's best to keep a safe distance and let the professionals handle it. And finally, carbon. Carbon is like the superhero of the element world. It's everywhere, making up the building blocks of life. I mean, you're made of carbon. Your body, your brain, your skin. Carbon is the key ingredient that makes you, well, you. Carbon is also super versatile. It can take on different forms, like a shape-shifting champion. It can be a sparkling diamond, a soft pencil lead, or even a mysterious black lump of coal. It's in the air we breathe, the food we eat, and the trees and plants that surround us. Oh, and let's not forget about carbon's role in technology. It's the superstar of the digital age, powering everything from smartphones to computers. So when you're scrolling through social media or playing your favorite game, give a little nod to carbon for making it all possible. That's why it's totally safe to touch carbon with your bare hands. Your hands are literally made of it after all. And it's not like that sneaky phosphorus that can set your fingers on fire. So go ahead, give yourself a high five. Chemistry is like a treasure trove of elements, each with its own unique story. Some might be safe to touch, while others require caution and expertise. But whether we're exploring the world of elements or our own daily adventures, let's always prioritize safety and curiosity. Have fun and stay tuned.
Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets sunshine similar to Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity, though. Let's imagine this. If there was a black hole as big as the Sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the Sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If a star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? It's a myth. Or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes the apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and, quote, perhaps not too far from a trampoline, but without the springiness and instability, end quote. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the Sun. Do you think this is a myth or a fact? This is a fact. Although the Sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails. Myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments.
Why do we look the way we look? Most of it's down to dear old planet Earth. Its atmosphere, gravity, that kind of stuff. When you go on a week-long beach getaway, you get a tan. Basic. But what about living on a whole other planet? One astronaut spent a whole year living on the International Space Station. Zero gravity means no healthy pressure on your body, so his bones got weaker. So did his muscles. It also gave him more space between his vertebrae, so he got a bit taller. And that's only a year. The more time you spend at the beach, the darker your tan gets. So, what if we move to Mars? The first major change you might notice, after a couple hundred years, is your brand new skeleton. Gravity on Mars is much lower than on Earth, so your muscles and bones would probably shrink. Not great for surviving on a new planet. Gravity would make us feel our weight differently. If you weighed 150 pounds on Earth, you'd only feel like you weighed about 50 pounds on Mars. You'd need to eat more to get stronger and bigger to make up for Mars's weak gravity. Sweet! Time to grow some larger and stronger bones, organs, muscles, everything. There'd be one more dramatic change. Your largest organ, your skin. It's the most important barrier that protects you from everything. Germs, wind, UV light, looking totally creepy, you name it, it does it. You might just need a whole new skin. How do you feel about orange? Sorry people, green skin is totally sci-fi. Here's the deal. Carotenoids offer quite a nice protection against UV light. That's the stuff you find in carrots, sweet potatoes, bell peppers, tomatoes, pumpkins. A Mars farmer's market could make a fortune. The more of these veggies you eat, the more orange your skin's gonna get. If you followed a special diet and wore high-tech gear, chances are, one day, living on Mars might be totally normal. Living on Mercury would be really tough. It's the closest planet to the Sun, and it's definitely hotter than Earth, but weirdly, not hotter than Venus. It's really hot during the day, about 800 degrees, but at night, it drops to -290. Days on Mercury are kind of crazy. You know, when you finish the day, but you didn't really get a lot done? Problem solved. Move to Mercury. A day on this planet lasts about 58 Earth days. That means you'd have a lot of time to get ready for bed. My guess, though, you'd probably get kind of bored. One excellent solution. Somehow, become made of metal, like titanium, nickel, or platinum. Those guys can handle extreme conditions. Life on Venus would be way worse than Mercury or Mars. Pressure might be a tiny issue. You'd probably have one long, never-ending headache. Standing on Venus is like being 3,000 feet underwater. Oh, and that thing we need every moment of the day? Chocolate. Air? There's not a lot of that floating around on Venus. There's carbon dioxide everywhere, and the planet's surface is completely dry. That means it's gonna be hot. 870 degrees hot. There are a few species on Earth that can survive the boiling point of water, and maybe if they mutated somehow, they'd survive Venus's crazy heat. 266 degrees is the record so far, set by a species of microbes. So get ready for an epic body transformation. Want to live on Venus? You'd probably have to turn into a tiny microbe just to survive. Luckily, Venus's atmosphere has phosphine, which isn't great for humans, but microbes just love it. But since you're not a microbe, not yet anyway, you'd need to wear special gear to control the pressure and feed you air. It's not looking good. Maybe it'd be easier on Jupiter. Yeah! No, it's got no solid land. This planet's made of hydrogen and helium and is known as a gas giant. Unlike Saturn, you'd probably end up just floating around on it. It's like a giant cloud, and if you ever managed to land, it'd be like walking through a super thick fog. Temperatures fluctuate a lot here. It's freezing on the surface, and the atmosphere can be super hot below the surface. We don't really even know. If you lived on Jupiter, there'd be no spoken languages. The gas planet absorbs radio waves, so even if you could speak, no one would hear you anyway. And there'd be no music, so no dance parties. What's the point? People would have to communicate in sign language. Great! But it's not. The atmosphere on Jupiter is wild. All kinds of winds and gas clouds. You probably wouldn't even be able to see anything. So that's not gonna happen. Still, Jupiter is awesome to look at. It's so big that it can fit all the other planets in our solar system inside it, with room to spare. A trip to Saturn will set you back about a decade, and it'd be a big old waste of time. Saturn's mostly made up of layers of gas. It has no solid surface, so farming, building, or any other normal Earth activities are out of the question. Before landing on Saturn itself, you'd probably want to explore those iconic rings around it. You'd fail though, because the rings are made of millions of ice sprinkles floating in space. That's pretty hard to walk on. You might have thought that Saturn was going to be a good fit for you. Some layers of this gas giant sphere actually have quite a nice temperature. If you dive into Saturn, you'll get to a layer with liquid molecules and a cool 32 degrees. That's like northern Canada, Alaska, Sweden, except that you can't walk on it. Anyway, it's only one minor layer, and the rest of the planet is insanely cold. So I guess if you still want to live on Saturn, you've got some work to do. No biggie, you just gotta turn into a snowball or something. What about Uranus? Time is kinda weird on Uranus, so if you're out that way looking for a nice vacation spot, definitely choose this planet. A 2-week getaway on Earth lasts 3 years on Uranus. There's even a sea if you're up for a beach vacation. The only problem is that it's made of ammonia, that gross-smelling stuff they use for cleaning. But watch out where you land. If you get it wrong, you might end up spending a whole year without any sun. How would you change if you had to spend a whole year in the freezing dark Uranus winter? We'd need bigger eyes to see in the dark, plus more of that thicker skin to keep the cold out. We might even develop a new hearing system, like dolphins have. Neptune. It's another gas planet, but scientists think there's probably a dense core inside. If you took the plunge to live on Neptune, you'd probably turn into a space reptile or cosmic fish, endlessly floating around on the surface. Gravity on Neptune is just a little bit stronger than on Earth. Still, it'd be really hard to stay in one place. The wind there is super strong. You'd have to be much heavier to resist it. Time to eat again, woohoo! But this planet's really impossible to live on. Scientists don't even want to send another spacecraft there. Welcome to Pluto. Freezing cold, tiny, and super far away. Doesn't sound too exciting. It's even smaller than our moon. It would be so hard to stay on the planet. No more trampoline parks, people. You'd probably have to build yourself a huge machine that would spin you around, sort of a fake gravity machine. Still, you try spinning around all day, you'd need a brand new nervous system to avoid feeling queasy all the time. But Pluto's not all bad. There's a liquid water ocean beneath the surface, and ice mountains. If you got yourself a highly trained crew and a bunch of expensive gear, and regular supplies from Earth, nah, too much hassle. Spaghettification. Wonder if you can choose your own sauce? It's actually something you might experience if you ever tried to live in a black hole. It's the process of squeezing objects, like you, into long, thin cosmic strips. So, good news, you'll get much taller. Bad news, you'll be thinner than a single human hair.
We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes, but it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own, and our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system. But these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot, you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth. And it gets 22 times more energy than we get from the Sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the Sun. And it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy. So it belongs to the class of super-Earth planets. Such planets can be rich in water ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live. But because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the 2 nearest planets are too hot. But the third planet looks more promising. L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about a third of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. The presence of water is the main condition for the emergence of life. But we can only guess where the water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super Venus class, L9859e. It's a rocky planet 3 times the size of Earth. The Super Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, The stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot, at a perfect distance from the star. Not too close, so that the planet isn't too hot, and the water there doesn't evaporate instantly. And not too far away, so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet F in this star system, located right in this sweet spot. This super-Earth candidate is 2.5 times heavier than our home planet. So we have hopes that it's a rocky world, just like the other planets in this star system. The weight of planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. The planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful, because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there's a slight drop in the star's brightness, that's when a planet has passed between us and the star, like this dot. We have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,715 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk. And they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts. But it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signals too. But so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us because we're always looking for life outside of our solar system. And super-Earth-class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called super-habitable. So some scientists think that Earth is a good place for life, but not the best. Super-habitable planets would have to be 30% larger than Earth and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This in turn would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This would make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the Sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the Sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy, besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the Sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, They expand and either absorb the planets around them or burn them up. One last thing, let's find planets in this pile that are in the habitable zone of the star. And voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them.
Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter, and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem – finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the rogue planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth. Soaring temperatures of more than 11,000 degrees Fahrenheit, solid rocks of blazing superhot fire, immense pressures 3.5 million times stronger than on the surface of the Earth. These are just some of the things cooking 1,800 miles beneath your feet as you're watching this video. How? The sun is burning with a temperature similar to our planet's core, but it's 93 million miles away. So why isn't Earth melting away from its own core? Our little blue planet is made of many layers stacked one upon another. The inner core, the outer one, the mantle, and the crust. The deeper you go, the hotter and more pressurized it gets. Plate tectonics are layers of the mantle and crust piggyback riding, forever moving and just having a good time. Scientists discovered there are 9 plates in total in different parts of the world. When these plates move and grind on each other, earthquakes occur. Energy is released as a result, and we feel it on the surface. Think of it as trying to shut a car door after stuffing it to the brim. When you realize there's something in the way, remove it and boom, everything topples. Billions of years ago, our lands were all interlocked in what was called Pangaea. But slowly, and I mean slowly, over the years, the continents drifted apart into what we have right now. The Earth was also cooler on the inside, but it slowly started generating more heat in the core. Earthquakes are measured with intensity and magnitude. We see how far the effects of an earthquake reach through magnitude, and the intensity is the measure of its power. Over at the mantle, the cooler rocks begin sinking and hot material from the core rises up. When this happens, the plates begin moving, and as a result, they create mountains, hills, and bodies of water we have today. None of these things happen overnight. It takes millions of years to actually see something. All the way in the layers of the Earth, there are different sources of heat, mainly from when the planet was initially formed. Friction heating occurs when materials begin sinking down to the center of the Earth. Since the Earth is surrounded by a solid mantle, the crust floating on top of it acts as a barrier to protect us from the Earth's insides. But the secret for its success is the difference between heat and temperature. Simply put, heat is just energy, and temperature is its density. If the Sun was 1,800 miles away from the surface of the Earth and boiling at the same temperature as our core, we would melt like ice cream on a hot sunny day. A shock from a small short circuit when plugging out your phone charger from the socket won't be too harmful, even though a spark can have temperatures of around 2,700 degrees. But if you dipped your body in a boiling bath of hot water at around 200 degrees, let's just say it's not worth it. Just because the temperature of the Sun's surface is roughly the same as the Earth's core, doesn't mean the heat distribution is the same. The Earth's core is teeming with iron throughout the layers, but on the surface, the iron atoms are arranged into cube shapes. That's when iron is in normal room temperature and regular pressure. But put in extreme conditions, the atomic shape changes into hexagons. For a long time, scientists thought that the iron in the core was hexagon-shaped, but they found out it retained its cubic formation 1,800 miles underground. Since the core has so much pressure, the atoms simply don't have a place to move to change their shape. If you were standing in a subway train that was packed full, you wouldn't even have space to lift your arm. But everyone inside is able to switch positions while keeping the original shape. That's why the structure of the Earth's core is solid and not liquid. The atoms are so tightly packed that they can't even transition into a liquid state. But in a world where the Earth's core liquefied, we'd witness the worst consequences, starting with major and mass volcanic eruptions, earthquakes, and tidal waves. Every major hotspot would be in danger, and the ring of fire would be a non-stop fountain of lava spewing out. Cool material from the upper layers sinks down to the core and vice versa. With a liquid and incredibly unstable core, this process would be much faster. Every major city and town by the coast would be washed away by tidal waves, and all the volcanoes erupting will blacken the sky with ash and smoke. This would temporarily block the sunlight from entering our atmosphere and eventually force anything flying in the air to remain on the ground. The lands we currently live on would feel like ice breaking away from a glacier and floating off. Many dormant volcanoes would wake up from their slumber and spew out their morning lava all over the place. The ground formation and structure would change permanently. Magma from the bottom of the ocean trenches would find its way up to the surface and change the currents in the oceans. The Arctic Ocean and Antarctica would melt away and add to the rise of water levels all around the northern and southern hemispheres, and eventually the world. Wildlife on land wouldn't be able to flourish, and all the greenery would disappear. Marine life would have to find a way to escape the changes in the ocean temperature. The world economy would crash as an international emergency would be declared to try and figure out a way to stop this. But humanity would barely make it alive and would have to strive to continue existing. Well, of course, something like this will never happen. But if the Earth's core cooled down, then we wouldn't have massive volcanic eruptions, no devastating earthquakes nor tidal waves. In fact, none of these things would happen since they require energy to function. The continents would stop moving and changing. Sounds cool, right? No. This means that the magnetic field protecting our planet would disappear. which would make us extremely vulnerable to cosmic radiation, as well as asteroids and meteorites. The sun's rays will feel even more intense than usual, which will make it extremely unsafe for anyone to go outside. The heat produced in the core is responsible for recycling the carbon that goes back to the surface. Now, recycling would stop altogether. Carbon is an essential part of carbon dioxide that plants need to survive. So all the trees and plants on the surface and in the water would stop growing and wouldn't be able to produce oxygen for the rest of the world. With cosmic radiation and lack of oxygen, humans would have to live in bunkers with artificial ventilation systems. The Earth's surface would become a no-go zone and start to resemble Mars. With nothing to power the Earth from the inside, it'd begin to dry up and crumble internally. Much of the Earth's surface is made out of oxygen, so without it, we would eventually see something like major sinkholes around the world. Sinkholes that can take down cities like New York and Paris, along with landslides in many cities and unstable landscapes all over the place. Every single city's infrastructure would eventually collapse and make the ground unwalkable. So even if you did live in an underground bunker, chances are the foundation wouldn't last and you'd be exposed to the cosmic radiation. But all of this can vanish in the blink of an eye if an asteroid comes falling down. Whether it's tiny or colossal, we would be seeing more of those than actual rain. Without a magnetic field, the Earth can't block any foreign object that flies through our atmosphere. If an asteroid the size of Rhode Island came falling down, the damage would be much more than with the Earth's core hot and running. With the ground as fragile as potato chips, the ripple effect would be much wider and cause more indirect destruction around us. The Earth would eventually collapse in on itself and break into pieces until it's lost its own gravitational energy. It'd end up being a bunch of rocks and pebbles floating around in the emptiness of space. But nothing like that will happen either. We're living fine with our solid hot Earth core. As long as it's doing okay, then we can keep on doing our thing.
You may think the Earth is pretty big, but the Sun makes up almost 99.9% of the mass of the whole solar system. The rest of the mass is made up by the planets and their satellites, asteroids, comets, gas, and dust. It's around 93 million miles away from our planet, but it keeps us warm every day. Its temperature is about 10,000 degrees Fahrenheit, but the space surrounding it is still cold as ice. To understand this, we need to distinguish between heat and temperature. Heat is the energy inside some object. Temperature is something that tells us if that object is hot or cold. When the heat is transferred to that object, it makes its temperature go up. When the object is losing heat, the temperature goes down. Heat can be transferred in 3 different ways. The sun does it through radiation. That means it's releasing heat in the form of light. Your body radiates heat too, as infrared waves. That's why thermal imaging cameras will detect that you're in the room even at night. The hotter the object, the more heat it will radiate. The temperature only affects matter. Since space is mostly a vacuum, it doesn't have enough particles for heat to transfer in any other way than through radiation. When the heat from the sun gets to an object, the atoms start absorbing energy, but the heat can't transfer since there's no matter in space. Those rare atoms and molecules in space will absorb the heat. And they'll simply stay that way, while the cold vacuum will stay cold. There's a lot of matter inside Earth's atmosphere, so the energy of the sun can transfer easily. But if you put an object outside of the Earth's atmosphere in direct sunlight, it would end up heated to 250 degrees Fahrenheit because it's matter made of atoms and molecules. The temperature of the vacuum is negative 454 degrees Fahrenheit. That means, depending on where you are, space can either burn or freeze you. The sun isn't actually yellow. It emits light over a wide range of wavelengths. We can tell both its temperature and color by the peak in its spectrum. For instance, cooler stars will appear red, and hotter stars will be blue with yellow, orange, and white stars in between. When it comes to the sun, the spectrum peaks at a wavelength we'd usually call green, but our eye perceives it differently. So, the shade of green in combination with other wavelengths from the spectrum is going to look white to the human eye. We generally see the sun as yellow because our atmosphere scatters blue light more efficiently than the red one. During sunrise and sunset, there's more red light in the spectrum of the sun, which gives us amazing sceneries. Sunspots are part of the sun's visible surface that are on average way cooler than the sun itself. They overlap with parts that have an increased magnetic field. These parts don't allow the release of heat to the sun's visible surface. That way, the rest of the sun's surface is 3 times brighter than those sunspots. That contrast makes them appear almost black. If we could take a sunspot apart from the sun and place it somewhere in the night sky, it would be different, as bright as the moon when we see it from the Earth. All the planets in our solar system spin in the same direction because they were formed from one protoplanetary cloud, except for Uranus and Venus. They have probably had some strong impact on them that made them spin in the opposite direction. But it's different with galaxies. They don't usually form the same cloud of dust and particles. Also, they're not randomly distributed across space. They come in filaments, dense, slender strands of dark matter and galaxies, with voids in between. Proto-galaxies are linked by gravitational forces in small areas of space. This is probably because of the distribution of dark matter throughout the universe. The matter in the filaments moves in a corkscrew motion and goes towards the densest area. So, there might be a common direction galaxies tend to spin, but it's mostly random. There's a possibility we'll see a lunar elevator one day. Yep, a cable anchored to the surface of the moon. It would stretch 250,000 miles. We wouldn't be able to directly attach it to our planet because both Earth and the moon are moving. But we could keep it terminated high in our planet's orbit. Some researchers believe we could build such an elevator for a few $billion. The moon has resources we could definitely use. A rare form of helium found there could be of use in fusion power stations on our planet. Also, we could take some other rare elements and use them in smartphones and the rest of electronics. So, after around 53 trips up and down, the elevator could pay for itself. The cable would be as thick as a pencil, but its weight would be around 40 tons. It could even be made of materials we already have here on Earth, with no need to invent something. There could even be a combination of 2 elevators. A spacecraft would winch up an elevator from the surface of our planet to a space station. Then it would be flung towards the moon. There would be another elevator to finally lower it down to the surface of the moon. Planets in our solar system have predictable and stable orbits, but gas-giant collisions could have happened at an early stage when a planetary system was still forming. In case of a head-on collision, 2 gas giants would merge. They wouldn't end up losing their mass, the materials in their gaseous envelopes, or the ones in their solid cores. Such a collision at a higher speed would cause the loss of the major part of the envelope gas, and very high speeds, boom, both planets are gone. It's different if it's not a head-on collision. If 2 cores manage to completely avoid each other, gas giants won't merge, but they'll lose some of the mass. Gas giants might even change their shape due to such collisions. Astronomers found out there's a galaxy extremely far away from us that looks similar to our Milky Way. We now see it as it was when the universe was only 1.4 billion years old, and now it's 13.8 billion years old. It took over 12 billion years for the light to come from this faraway galaxy and reach our planet. This galaxy is peaceful, stable, and surprisingly non-chaotic, unlike all other galaxies that were quite turbulent in their early stages. To leave the Milky Way, we'd have to travel around 25,000 light-years away from the center of the galaxy, or 500 light-years vertically. Our galaxy is a disk of stars that spreads around 100,000 light-years across and is 1,000 light-years thick. The Sun, its central star, is located halfway from the center of the galaxy and close to the middle of the disk in the vertical direction. We'd have to go further than its edge to get away from the halo that surrounds the Milky Way, old stars, diffuse gas, and globular clusters. If you wanted to go even further to see the Milky Way in all its glory, you'd have to travel 48,000 light-years vertically. At this moment, we don't even have a telescope we can send there. There are central stars that eat planets. Our solar system is stable, unlike many other planetary systems. So we don't have to be afraid the Earth or some other planet will change its orbit and go towards the Sun. But at least a quarter of other planetary systems with orbiting stars similar to the Sun have a pretty chaotic past. In some of them, there are planets that used to move around, and their unpredictable migrations have disrupted the paths of some other planets, or even pushed them outside of their orbit. That means some planets probably have fallen into the central star. When that happens, the planet gets dissolved in the outer layer of the star, which means it gets eaten.
Mercury, about 3.8 billion years ago. A huge asteroid is about to collide with the planet. Boom! Fragments are flying in different directions, along with the blast wave. When the dust settles, we see a crater almost the size of Lake Ontario. The most interesting thing here is the shape of the crater. It looks like a spider. A round body in the center, and a bunch of legs that spread out from the crater in different directions. But the strangest thing is that the spider's legs don't quite line up with the center. Scientists can only guess how such a landscape was formed. Some think that the picture of the spider appeared there much earlier, and the meteorite falling almost into its center was just a coincidence. But we still don't have a clear explanation of how such scars could have appeared on the surface of Mercury. Another mystery about Mercury is how it was born. One theory claims that the planet used to be Venus's moon, but over time, it succumbed to the sun's gravity. The star literally ripped Mercury away, and the little planet began orbiting it. What might prove this theory is the rotation periods of Mercury and Venus. Mercury is gradually losing its rotational speed. One day on this planet now equals 58 Earth days and continues to increase. At the same time, after losing its heavy load, Venus has started rotating a little faster. Another theory says that Mercury collided with Venus shortly after the appearance of the solar system. At that time, Proto-Mercury was slightly larger than the planet we're familiar with these days. But then, Mercury lost part of its crust after colliding with Venus. And a little later, Venus collected this debris. But scientists still can't come up with a definitive answer as to how Mercury was formed. Uranus, a gas giant, 18 Earth-Sun distances from our home. This planet seems calm compared to other giants, like Jupiter with its Earth-sized storms. And still, Uranus has something unusual to boast about. This dark spot, for example, was detected by the Hubble telescope in 2006. At that time, it was almost twice the size of Alaska. A few years later, bright spots appeared there. It turned out that they were methane clouds that moved across the surface of the planet at a speed of 300 miles per hour. But we don't know what exactly causes such storms on Uranus. Maybe we can solve this secret by looking at another mystery of Uranus. This planet rotates while lying on its side. If you look at the axis of our planet, you'll see that it's vertical and only slightly tilted. It's the same for most of the planets in our solar system, but not Uranus. Its axis is almost horizontal and pointed toward the sun. One of the poles of Uranus is fully illuminated at almost all times. The polar day on the planet lasts for 42 Earth years. When the tilt of Uranus's axis changes, the polar day starts on the other side of the planet. The other pole plunges into darkness for 42 years. This change of seasons can cause severe storms on the planet's surface. But why exactly Uranus lies on its side is unknown. Perhaps billions of years ago, the gas giant collided with several asteroids that were about to become a young planet. Such a protoplanet, similar in size and weight to Earth, could have tilted Uranus after crashing into it. But it's still just a hypothesis. Now let's go to Jupiter's moon, Europa. The big mystery here is whether there is life on this moon. Scientists don't deny such a possibility. All you see on the moon's surface is ice. The stripes you may spot are actually long, wide cracks. For a long time, scientists thought this moon was nothing more than a block of ice. But now, they think there might be liquid water inside. The core of Europa is heated by the tidal forces of Jupiter. This warm core melts the ice around it, so there really could be a huge ocean under the ice crust. Since water is the basis of life, different microorganisms could exist there. But we would only find out if we sent a probe there. we would have to drill through 24 miles of solid ice and start searching in an ocean twice the size of all water reservoirs on Earth. Look at Saturn's moon Titan. It's the second largest moon in the solar system. It's 50% bigger than Earth's natural satellite. It's the only place in our solar system, other than Earth, where liquid water has been proven to exist. But the most interesting thing about Titan is its atmosphere. It's 250 miles thick. This distance is almost 40 times greater than the average cruising altitude of commercial planes on Earth. And it's 95% nitrogen. For comparison, Earth's atmosphere is 79% nitrogen, which means they're quite similar. The mystery is that no one knows how this atmosphere appeared there. One theory suggests that many years ago, meteorites hit Titan's surface almost non-stop. Massive rocks collided with the crust, raising the pressure and temperatures on the moon. Under such conditions, the ammonia in the air decomposed into nitrogen and hydrogen. The heavy nitrogen fell on Titan's surface, while the light hydrogen rose and flowed out into space. But some scientists dispute this theory. Another mystery of the solar system is the hypothetical star Nemesis, and whether it really exists. If you look at all the stars of our galaxy, most of them are paired, which means that two stars orbit around each other. Statistically, the Sun must also have a companion. So, some scientists have made an assumption that the largest mass extinctions on Earth were related to some mysterious object in space. They hypothesized that there was a red dwarf somewhere within 1.5 light-years away from the center of the solar system, and every approach of this dwarf star to the asteroid cloud disturbed these space travelers. Every time it happened, several asteroids began their journey toward Earth and caused a mass extinction. But this star hasn't yet been discovered, and many scientists question this hypothesis. Now let's look at the very edge of the solar system. A photon of light has to travel 1 year to get here. Scientists believe the Oort cloud exists in that area. It's a hypothetical region where tons of asteroids and blocks of ice gather into clouds. It's the furthest place where the sun's gravity still works. Presumably, this spherical cloud wraps around the solar system. This is the region where long-period comets are thought to originate. They fly all the way through the solar system and then return to the Oort cloud. This journey can take thousands of years. Even more exciting, there could be a gas giant called Tyche in that region. Some scientists say it might be 4 times the size of Jupiter. So far, no research has confirmed its existence. Although the Oort cloud is still considered hypothetical, some scientists believe that comets from that area are responsible for the major mass extinctions on Earth. Now let's go beyond the borders of the solar system. There, 1,500 light-years away from Earth, there's the closest to our home planet black hole. Black holes are the most mysterious objects in the universe. They're so heavy that they attract not only matter, but also light. Even more, they slow down time. Once something gets trapped in a black hole's gravity, it never escapes. Light and matter gradually settle near the event horizon and soon disappear into infinite darkness. Time flows differently here. 1 minute near a black hole can be equal to weeks on Earth. The biggest mystery is what exactly is inside a black hole. Some speculate that there's nothing but crushing pressure that destroys anything that gets there. Others say it might be a portal to another dimension or a wormhole to another place in the universe. If it was true, white holes would exist as well, as exits from black hole portals and wormholes. But no white hole has been found so far. Now, how about going to the hypothetical border of the entire universe? It's called the Eridanus supervoid. If you look at the map of the universe, you'll see an empty cold spot about 1 billion light-years wide. The entire Milky Way galaxy is only 100,000 light-years across. The main mystery is how the spot appeared. One theory says this void is the scar left by the collision of 2 parallel universes. Imagine that universes are giant bubbles, and one day, 2 of these bubbles collided. That's when the parallel universe ripped several galaxies out of our bubble. So far, this is the only explanation for how such a huge cold void could appear in our universe.
This may look like a scene from a cool sci-fi movie or an astonishing painting, but it's actually real-life footage of Mars, the very planet known for its bright rust color. Layers of rock and dust cover the planet's surface. They consist of iron-rich minerals. That's why dust on Mars is mostly iron oxide. It floats in the atmosphere and creates an orange-red haze around the planet. But Mars has some even more amazing things, like these blue speckles on its surface. They look like a wind-sculpted sea of dunes around 19 miles wide. Astronauts saw these dunes at the northern polar cap of the planet. That's a region that covers an area approximately as big as Texas. The blue dunes, formed by winds, are shaped like long weaving lines. The winds on Mars are relentless and strong. They turn the barren surface of the planet into terrains of grand beauty. These winds are influenced by many different factors. For example, temperature fluctuations to the way the planet's atmosphere circulates. The atmosphere is thin on Mars. That's the reason liquid water most likely can't exist there for any long period of time. That's why, even though Mars is only half the diameter of our planet, it has the same amount of dry land as Earth. A thin atmosphere is also the reason why wind needs to be exceptionally strong and fast to move the sand and form such shapes as these dunes. Winds usually move at 10 to 20 miles per hour on Mars. Anyway, even though the image looks pretty colorful, the dunes aren't actually blue. The bluish patches represent colder parts, while the warmer regions are yellowish-orange. The images were part of a set of photos released to celebrate the 20th anniversary of Odyssey, a spacecraft orbiting Mars. Mars has numerous sand dunes in different locations all over its surface. Some of them formed 1 billion years ago, like the ones in the Valles Marineris region. They haven't changed because both the atmospheric pressure and wind patterns there have remained the same. But some things do change. For example, some dunes get covered with frost. Here, the main dune has a series of dark patterns. It may be because frost comes and goes, depending on the season. Mars has 4 seasons, just like Earth, but they're twice as long as ours. It's because Mars needs around 2 Earth years to orbit the Sun. Seasons are harsher in the south of the planet than in the north. During southern winter, the planet is farthest away from the Sun. Mars moves pretty slowly, and its orbit is elliptical, different from the orbit of Earth, which is almost circular. Spring on Mars is a season with plenty of dust storms that start in one part of the planet and, eventually, turn into huge storms. They become so large, they blanket the entire planet. Each planet of our solar system has something that makes it special. Jupiter, for example, is not only the largest planet, more than twice as big as all other planets combined, but it also has the biggest ocean in the solar system. Jupiter is made of similar elements to the Sun. They're mostly helium and hydrogen. In the deeper parts of the planet's atmosphere, temperature and pressure increase. That's why the hydrogen gas gets compressed and turns into liquid. That gives Jupiter the biggest ocean, but it's made of hydrogen, not water. There's also a theory that somewhere halfway to Jupiter's center, the pressure increases so much that electrons start getting squeezed out of hydrogen atoms. This allows the liquid to conduct electricity as effectively as most metals do. Jupiter is rotating fast, which creates electrical currents and generates a strong magnetic field. But as a gas giant, the planet doesn't have a firm surface. The planet's swirls and stripes are cold, windy clouds of water and ammonia. Jupiter also has the iconic Great Red Spot, which is an insanely large storm with crimson-colored clouds spinning counterclockwise. Winds there are way faster than any hurricane on our planet. The Great Red Spot has slightly changed throughout time and is currently bigger than our planet. It's 1.3 times as wide as Earth. Scientists have discovered that its roots extend more than 200 miles into Jupiter's atmosphere. A regular tropical cyclone we see on our planet can only extend 9 miles from the top to the bottom of the storm. These days, the red spot is becoming smaller and taller at the same time. Jupiter also has dozens of moons and a couple of rings, but unlike Saturn's rings, these are quite faint and mostly made of dust, not ice. Also, there's a salty ocean under the surface of Jupiter's biggest moon, Ganymede. It's hidden below a thick icy crust. It's likely to contain more water than all surface water reservoirs we have on Earth combined. The theory says this ocean is around 60 miles deep, 10 times greater than the deepest point of our planet's oceans. Jupiter and Saturn contain 10 million tons of precious stones. The pressure inside these planets' atmospheres can actually turn carbon into small pieces of diamonds. If you put these diamonds under extreme temperatures and pressure, they can melt. This would probably result in some sort of diamond rain. In the beginning, our solar system was just a swirling cloud of gas and dust. It eventually developed into a spinning disk with the central star in the middle. Almost all planets in our solar system move counterclockwise around the sun. Venus is the only planet that rotates in a clockwise direction, and Uranus rotates on its side. These planets are most likely different because long ago, huge asteroids collided with them and kinda knocked them off their course. There's a chance Venus could be a habitable planet. It's definitely not a place you'd want to live now, not with its sulfuric acid clouds and tremendous atmospheric pressure. It's 90 times greater than that on Earth. Add here insanely high temperatures. The conditions on Venus are very unfavorable for people. At 863 degrees Fahrenheit, Venus is hotter than Mercury, even though it's further away from the Sun. This happens because there's too much carbon dioxide in Venus's atmosphere. It traps heat, which causes the temperature to rise way higher than it's supposed to. But simulations showed that around 700 million years ago, Venus might have been a nice place with moderate temperatures and liquid water. Those conditions were slightly similar to those we have on Earth now. Uranus is not a gas giant. It's actually made of ice. The atmosphere contains methane, which makes the planet look blue. It has 27 moons, 2 sets of rings, and lots of ice in its atmosphere. A day on Uranus lasts just a little bit over 17 hours. That's how long it takes the planet to complete a single rotation on its axis. But its tilt is so pronounced that most of the time, either one or the other pole is pointed toward the sun. That's why the daytime length at the North Pole is almost half a year, and a year on Uranus is as long as 84 years. If you lived on Uranus closer to its North Pole, you'd be able to see the sun in the sky for 42 years. That would be the summer. After this, the sun would go down, and you'd have to live the next 42 years in the darkness. It'd be the winter on the planet. Neptune is the most distant and the smallest of the gas giants. The gravity on the planet is similar to the one we have on Earth, but you wouldn't be able to stand on Neptune's surface. It's gas, not solid land. Triton, the biggest of the planet's moons, orbits Neptune in a very unusual way. It moves backward compared to the rest of the planet's moons. Triton is also slowly spiraling inward toward Neptune. One day, billions of years from now, it's likely to get torn apart by the planet's gravitational forces and become just a ring around Neptune. This ring will continue being pulled inward until it eventually crashes into the planet. Pluto is a dwarf planet, and a year there lasts 248 Earth years. But even though it's not even a planet, Pluto still has several interesting things to offer, like floating mountains. Pluto's nitrogen glaciers carry countless isolated hills, each up to several miles across. They're likely to be fragments of water ice from the dwarf planet's surrounding uplands. Nitrogen ice is denser than water ice, so scientists think water ice hills float in a sea of frozen nitrogen, just like icebergs in the Arctic Ocean here on Earth.